Just give me some sort of signal when you want the slides changed.
Oh, okay. Yeah, I'll just say okay every time we want the slides changed. All right. So yeah, so this is so hello everyone. This is our project, an AR tool for visualizing different poses, pretty much. Okay. So the project objective, so this is our project overview. So the core objective of our project is to teach beginner and intermediate artists to draw the human model by tracing from a figure projected in augmented reality. Many beginner artists struggle with making realistic poses, and few hands-on dedicated art programs effectively teach anatomy. So this program, what it essentially is aiming to do is making the process of making a highly customizable model accessible, quick, and adaptable for AR drawing. So for this project, the user can pose a character using inverse kinematics with camera rotation using touch controls. They can move and create lights and change the color of intensity for shading experimentation. And the selection to switch between realistic and stylized models, and blend shapes to affect attributes for those different models. Shader customization for even further experimentation if you want to get wild. And most importantly, the AR drawing portion with interactive tutorial panels that will take you through the steps of drawing the desired model that you make in the editor, pretty much. So, okay. So yeah, so before development started with this project, we performed research on a few different related projects. So we looked into an augmented reality support system for teaching hand-drawn mechanical drawing, and we looked into how augmented reality applications are developed for projection drawings, and also a 3D virtual drawing mobile application framework by using, it's using AR framework. It's it's a 3D sorry, oh my god. And lastly, we also looked at Densirac, which was a program that estimates pose from looking at a model that you point a camera and it basically gets all the key joints, and it makes a model which then projects in AR. So yeah. Victor's going to talk about the one. So yeah, Victor's going to talk about the one that we found the most integral to our project. So yeah, take it away, Victor.
Yeah, so one of the papers that we took inspiration from was the development of mobile applications of augmented reality for a project with projection drawings made by a group from Ukraine. This paper mainly talked about how real models sometimes have a high cost and a limited access, and that their application solves that issue while also teaching the users 3D space orientation skills, spatial imagination, and many others. Their application and objective for their project is very similar to ours, where it aims to teach users how to draw certain models, while also learning at the same time the 3D spatial skills I just mentioned. And luckily, they also use Unity 3D, which made us incline even more towards the use of the Vufara engine, which they did, and we decided to do as well.
Yeah, so speaking of Unity, we actually developed our first prototype in Unity, and we originally made it for a PC interface. So the project basically consisted of moving sliders for rotating limbs on the X, Y, and Z axes, as well as being able to adjust the X and the Y scale of the model. And while it formed a strong basis for the project, it was far from ideal upon further testing. And because using sliders, for one thing, was extremely limited, and it didn't let you freely customize the limbs to the extent that we probably wanted. And also webcam, the way we set it up was you scanned a QR code and then you put it next to your desk, but it didn't really feel like hands-on enough. Like it just felt like a reference, and at that point it might as well just be like a regular you might as well just take an actual model and look at it on your screen, because it's essentially what we were doing. So we had to sort of shift a bit. So we shifted to mobile. Yeah. So it was decided that sorry about that. Hold on a second. So it was decided that our project would be transferred to mobile because we discussed various methods on how we could potentially improve our drawing tutorial. And ultimately, the most feasible solution was having the user hold their phone with their non-dominant hand while they draw with their dominant hand. In addition, also touch interface allowed for new accessibilities that haven't existed before, including using touch areas to move the limbs with IK, making it far more flexible and just easier to use. So Jason is going to present a demo that we made, or not a demo, it's our final project, but yeah.
Yeah, so I have, there we go. It's just my phone screen. Let me see if I can just open up the app. You all can see the phone screen application on my screen.
Yep.
Yeah, maybe enlarge it a bit, yeah.
So as you can see, not using my mouse, it is actually using the touch screen on my phone. So you can just take these little the spheres and move them around, and it moves the arms and legs of the model. We have when you hit the add light button, it makes a light, and it can be moved wherever in 3D space. You can fiddle with the color of the light and the intensity. We have a few sliders just to get different models. So we have the weight slider, muscle slider, height slider, and then we have arm and leg length sliders. We have a few different shaders programmed into the system. So we have a comic shader and a high contrast toon shader. It just requires the light to use because otherwise, so if I delete it, yeah, it just becomes completely black, basically. We have a tutorial just running through all the different sliders and buttons. This is in editor mode. We have a different tutorial when we switch to AR. So then we just can change the background too of the little editor. So I'll just switch to AR. And I'll flip back to, okay, put that in the center. So if you can see we have a tutorial, like an actual drawing tutorial set up. And I will get a QR code. Yeah. So yeah, what's on the page there is one I drew earlier using the app, but basically, yeah, just using the QR code, you can see it's just kind of like parented to the QR code, and you can trace over the pose on a piece of paper, like a piece of paper you put it on.
Yeah. Also, we implemented a Sobel shader. It's kind of hard to see on this specific toon high contrast shader, but
yeah, let me fix that. I'll just back. And I will put us back.
It's useful for the drawing, but
sorry, let me just flip that and flip that, and there we go. Oops. Oh, I didn't.
Yeah, you need to put it in
there. We go. Yeah. There. So yeah, so you can see it. It gets all the lines, like the interior details. It runs an outline around the perimeter of the model, and it does get most of the interior details where like the arms, the shape of the arm muscles and the rib cage and all that all intersect on the model. So,
yeah, we were actually having a tripod would make it easier, but we were mainly thinking of the accessibility we were discussing, we were joking, we need a tripod, but
it's just an issue of like, it's nothing we can't program a steady, like a physical object to hold the phone. That's just a matter of what the user would have on hand to be able to like keep the system steady, basically.
Yeah, pretty much. Yeah.
Yeah. So I'll just switch back to the there we go. Okay.
Sorry about that. So yeah, so these are the programming contributions that were done. So each of the programmers will discuss what we've done pretty much.
So for the IK and camera rotation, using the fast IK plugin, we implemented inverse kinematics. We were able to restrict the 3D model's movement to allow for natural movements. This prevents the model from being manipulated into unnatural positions, making it easier for the user to adjust the model to the desired pose. The script I made basically allows us to apply an orb onto any joint we choose and reposition the rig accordingly, and also rotate around the rig so you can get different vantage points and perspectives.
So yeah, so I was responsible for basically overhauling the AR drawing tutorial that we had. So it was heavily based on the previous one we had because it actually requires a QR code. We were looking actually into using Arizon ARKit, ARCore, but from my experimentation with them, like none of them were working super well. The plane detection was kind of a little inaccurate, but using a marker upon further testing, actually, like as long as you don't block the marker or move it, then it actually stays the same in the same position in the virtual space that you're holding your phone up to, pretty much. So the way that I pretty much made the model project to an AR target was basically just make the model a child of the image target and just offset it vertically, so the user has space both to look at the trace that, or to look at the model that they're tracing, but also to look at the tutorial panels at the bottom. So we're using a lot of we're properly using screen real estate in that sense, pretty much, and it's effective. I've used the tutorial numerous times, and I was actually able to draw a model really well. So yeah.
So the user is also able to create it, and as you could see on the demo, they can create and delete as many lights as they want to customize how the model looks as much as possible. We can select which lights adjust by clicking on them, which is done by setting a pointer to the one selected, and then activating their own canvas with all the UI buttons and sliders in it. To deselect, all we need to do is set the pointer to another light or to null and deactivate set canvas.
So for the, if you want to go back to their slide real quick.
Sorry?
Yeah,
Oh,
no worries.
sweet.
No worries. So for the lighting, we basically use the Unity's built-in or like on drag and on move functions in order to actually have the lights move around based on their position in the world. And the other thing we set up was RGB values for the lights, so we can change color, and then that way, with like the tune shader as an example, we can actually, or with the additional lights that we add, we can actually see the colors change real time and use that to kind of mix and blend lighting colors on the model, as well as adjust our intensity for how bright our light's going to be. And so so for the shaders, so for the comic shader, the way the comic shader works is we have our light shadows be adjusted with our comic texture to outline the edges of our shadow. We have a custom function that takes the direction of our existing light source and performs dot product on it with the normal, or with the model's normal vector, in order to get the shadow edge for a model. We pass this through a smooth step function to adjust the amount of shadow existing on our object, and divide that by a given threshold amount. And finally, we are lerping between our object's texture color and white, given the time being the multiplication of our comic texture and our light direction. We then clamp or remap this into a 0 to 1 space for lerp, and then that way our 0 to 1 will be adjusted by our existing parameters that you can see below that are added to the shader. Texture density changes how much our texture is scaled. So basically how big the texture dots are going to be on our comic shader. Offset will adjust how much texture there is versus normal shadow. threshold will decrease the amount of shadow on our object. And then obviously we have like a classic halftone dotted texture that we apply to it. And now for our toon shader, it's basically just it works exact same, classic way that we had to do in OpenGL, where we have our n.l value to calculate our basic lighting attenuation, and taking that and multiplying it with our ramp texture. So the one we use is just a basic black to white gradient. Adjusting our ramp based off of our attenuation number to either be black, gray, or white. And then for specular, it's basically just approximated with the light direction and the camera direction vector, and it's just how close it meets to the surface normal.
Yeah, so now we're going to discuss the artwork contributions that were done by our artists. So take it away.
Okay, so on this slide, we're going to talk about the models we used. We used a couple. One was more realistic, and we got that one based on the work from Svetomir Georgiev, who was on ArtStation, and Marat Ladipov, who's also on ArtStation. He made the stylized model. To get them to work with our project, I was the one who adjusted them to fit the same rig, so they would have the same matching arm positions. And I also adjusted them so that they would be able to have their shape keys. I set up the different muscle and fat values. Ended up getting some complex stuff. I tried to look up different fat distributions on male versus female bodies to make sure it would all go in. All right, and the next one. Yeah, getting the blend shapes. Ultimately, we had the fat, the muscle, the height, and arm length and leg length were actually, I think, handled by the bone lengths, not the shape keys. There was a little bit of trouble getting them all in. It was quite a bit of back and forth, but we eventually did manage to get them all in. Yeah,
eventually it took many tries.
Yeah, I didn't know that you couldn't bring shape keys if you had modifiers applied in Blender. That was a headache.
Yeah, pretty much, yeah.
Yeah.
Okay, so for the user interface, the UI is designed to help the user navigate through the application and be able to pose the model. We have UI for each of the model options available to the user, including gender, height and weight, arm and leg dimensions, and muscle definition. We also have UI for other settings, such as whether the model is 2D or 3D, or whether the desired skybox is day or night. As you can see here, the UI is made to be very simple and easy to understand. And the placement of the UI was also important to communicate the most important elements to the user, ensuring that all relevant options are easily accessible on the screen.
Yeah, after creating the script and UI assets in Unity, these had to be arranged and scaled properly to maximize the visibility of the model so the user can clearly see it. Therefore, we decided to move most of the UI elements to the sides of the screen while the model stays in the middle. We also had to make changes when we implemented functionality for mobile devices because not only the screen is smaller, but also using buttons and sliders could be difficult if they're too small. So like any other application, we decided to make everything bigger than they would originally be if this was a computer-only application.
The day and night skyboxes were created to test lighting conditions and create a more visually appealing environment. When using augmented reality, dialogues were written to outline the different steps. The steps were thoroughly designed for the best overall user experience. The light bulb model was also created to add more polish to our scene.
So the outline shader was, I coded it using a tutorial that I have in the link there. I originally had planned for it to just show the outlines, but because it's a screen space or a camera view rather shader, it takes the depth and the normals from Unity's camera and it overlays the outlines on top of the model. So if you use transparency and the alpha in any of these solid meshes, it messes with the outlines and they can't be shown. And unfortunately, I couldn't find a way to just show the lines and turn the model invisible so that you could trace the interior detail through the when projecting to AR. The tutorial panels it's just a quick tutorial that Seth threw together the script for. The images were sourced from the drawingsource.com there, just to have a more visual basis to show. It's just meant to show users how to plan out their drawing using the app, basically. And other than that, we have tutorial on like how all the buttons work, just in case they're not descriptive enough, the images, the UI images to use.
So sorry, hold on a second. So yeah, in conclusion, this project turned out to be, it turned out to be exactly that. It was an effective tool for teaching users how to draw a pose in AR. Over the past month, there were some technical difficulties in the process to mobile, but ultimately the sacrifices that were made were worthwhile. So the project is now accessible to newer and intermediate audiences, and artists now anywhere could use this pretty much. It's an effective tool. Thank you for listening. Actually, wait, I also wanted to mention our future works, because there were some steps that unfortunately we missed with this specific build. So one of the major things that we wanted to implement was computer vision. However, just because of time constraints on my end and bad time management, I unfortunately didn't manage to implement computer vision in such a way that that could be used in the project, because of the way that OpenCV specifically uses how it gets the webcam information, because it normally gets a raw image target as opposed to a camera. So I will look into that to try to get that, because that's the most important next step, just to recognize, I guess, the shape. Or I was just trying to find a way to like use tracking, but yeah. So, and another thing is adding further customization options, potentially maybe adding hair or hats or whatever. That's always fun, I guess. And also another important thing was the ability to go back and change the model, because that was something I actually wanted to implement, although I just forgot to do. But yeah, so thank you for listening. And here are resources, but yeah, thank you for listening.
Awesome, thanks Matthew and group.
Yeah.